We already used the count array method to get the size of temp and cust arrays after reading into them from the two text files, the payment.txt and customer.txt. In addition to count, first and last methods return the content of the first and last array element by position. For numerical arrays, min and max find the two elements with the smallest and largest value. Average finds the average of all array elements, and sum adds them all up. Also, we already showed how array copying from temp array to mth payment with C double conversion can be accomplished with a simple for next loop. Typically, the loop starts with 0, ends with the upper bound or size minus 1, and each array element is referenced by the loop index. Some people prefer to start with 1 and go up to the array's size using I minus 1 as the index. We're not going to do that. We will use the zero-based approach in this class unless there's a compelling reason to use the one-based indexing. One way to sometimes avoid indexing altogether is to use the for each loop, where the looping variable is of the array data type, like pmt double, rather than an index I of type integer, as shown at the bottom of this slide. One drawback is that you can't alter the value of array elements with this loop. Also, the fact is that this type of loop is used for more complex objects, where indexing is not necessarily the most natural approach. We are not likely to use for each as much in this class, although we will use it a little bit. So back to our payment calculator project. What we want to do is in the display loan button click event, we want to again demonstrate the count method as well as the first and last methods, and then also use the for next loop that we already created to add these customers into the LST payment or LST loan list box. Then we also want to use the payment stats button click event to demonstrate some of the numerical methods like min, max, and average to display the smallest, largest, and average load payment. And then we're going to go back and discuss why is the minimum 0, and specifically why is average so low. So let's switch to the payment calculator and go to the top of towards the top of the button display click event right after the listing, the clearing of the list, and you're going to use the add method. I'm going to kind of lazy, so I'll copy a part of it here to again demonstrate the count method by counting number of okay, let's go to number of customers. Okay, and we're going to tab that in once and then show the number of customers. Okay, then I'm going to modify this to display the first customer. First customer using cust array and the first method, and then I'm going to copy that and paste it for the last customer and demonstrate the last method of the cust array. Okay, so at this point I should get 10 customers, the first and last names, and then the list of customers and monthly payments from the previous recording. Okay, so number of customers is 10. The first customer is Eileen, last customer is Austin. Okay, and then there's the list with Eileen first and Austin as last, including their payments. Okay, so what is next? We're going to scroll down to the payment stats click event procedure, and in that one we'll demonstrate the three sort of numerical array methods and display the minimum, maximum, and the average monthly payment in the three text boxes called txt smallest, So monthly payment, MTH payment array, PMT array, its min method. Okay, so that gives us the smallest of the 10 monthly payments, and we can then convert it to string with currency format. And we're going to copy paste that and change it to largest, and this to the max method. And then finally we'll change this to average, not rate, to average payment, and the function is, I believe, a average fully spelled out. Okay, so one more time, save all the changes, run. Display loans if you have to see the previous results, and then click on the payment stats. So the smallest payment is 0, the largest is 3,000, right? So the 3,900, almost $4,000 is, where is it, is the fourth payment for Ted. Okay, obviously instead of 0 we wanted, I think it's this 1,000 and change for Helen. Okay, but the reason we got 0, because if you remember, in addition to these first element of MTH PMT array, there is another 90 that are zeros, right? And this is why the smallest payment is 0, and this is why the average payment is such a low number, $200, where clearly the average is somewhere in a $2,000 range just by looking at these numbers. Okay, so I'm going to close that, and then we are going to do something about this in the next few slides. Okay, the next thing we need to discuss is the upper bounds and redimensioning of the arrays. So, as we already saw, Visual Basic allows us to declare an array without specifying the upper bound, and have it be implicitly sized after the contents of the file is read into it from, customer.txt or payment.txt text file data files. For our MTH PMT array, that was explicitly sized to be 100 with that, a top dim statement and upper bound of 99. We can use a redim or redim statement to dynamically change upper bound, and in this case cut MTH PMT array down to size 10 in this case, because we don't need the remaining 90, at least not right now. The only issue is that redim statement reallocates the same memory addresses and wipes out any existing values, which in our case would be those 10 monthly payments, which essentially reinitializes the array to its default values, zeros for numbers and nulls for strings and so forth. Okay, we're going to need to use the preserve keyword, preserve redim, or when redimensioning an array, to avoid losing existing content, as example of the bottom of the slide shows, right? So here we have only 2 customers, okay, instead of 10, so we have those 8 zeros from the previous recording. If we redimension this to a size of 2, right? So this is size of 2, upper bound of 1, then both are reinitialized to 0. If we redimension with the preserve keyword, then those 2 original values that were entered or assigned someplace of the 2 actual monthly payments are still there. They're not wiped out. Okay, so to demonstrate this redimensioning and preserve effect, we're going to consider adding redimensioning to a monthly payment, MTH payment, okay, using determined from temp array before the conversion loop in the code, which I'll show you in a minute, because at that point all 100 MTH payments are still 0. The redimensioning will just cut the size from 100 to 10, reinitializing MTH payment to all zeros again, but since they were all zeros to begin with, this does not have any adverse effect. Okay, we'll click both buttons. We'll run the program to confirm this. Now what we're going to do is then add the redimensioning after the conversion loop, and then you'll see that the MTH payment array is now completely wiped out. Okay, running either or both of the buttons will give you all zeros, as you'll see in a second, for both arrays and stats. So we're going to have to then modify the redimensioning statement by adding the preserve keyword okay, after it, and you will see that then the contents is preserved, and running those two click event procedures for the third time will result in the familiar results from the previous run. So let's go back to the project and actually do this. Okay, so what we'll do is we'll go towards the top. We'll go towards the top right here in the form load. Okay, we'll go after we find how many payments are actually there, and we're going to redim the array num payments. I'm sorry, redim the mth pmt with num payments -1. Remember, num payments again is the total number, 10 in this case, so this is going to give us that 9 we need. Okay, before this is done before the conversion, okay, there's going to be no effect. All right, this is going to reinitialize the arrays to zeros, but those were zeros to begin with since the beginning. So once we save and run this, okay, hit the display loans, you'll see that all the values are there, the customers, the payments, okay, all the way down to Austin Powers payment stats now. Okay, because the array is cut down to size, you'll see that the smallest payment now is $1,000 rather than the 0, and the average payment is squarely in the 2,000 range, as one would expect, rather than that tiny $200 we had before. So now the reminder of that array, those 90 zeros, are all gone. Okay, if you close this and if you move the redimensioning by cutting it from before the conversion to after the conversion, which is essentially the assignment, right? So now this line or lines throughout the loop essentially assign those 10 elements, okay? And you'll see how the redimensioning then wipes those 10 out, cuts down the arrays to size, but it also wipes 10 out, and you get all the zeros. Watch. Run this, hit display loans, you get all the zeros, and obviously when you hit payment stats, you get the same thing. Now, by adding, after redimensioning statement, preserve statement, okay, saving and running will get us back the same numbers we had before and the stats. So hopefully this clearly demonstrates the concept of resizing, redimensioning an array and preserving versus wiping out its contents. Okay, so now we're going to go back to the presentation.